Thank you very much. Somehow I always follow the quantum guy. I'm not sure why that is. And in tying his great talk into mine, I'm old enough that I learned to code. I grew up as a data scientist, and I learned to code on a mainframe. And the place that I worked, we named all of our mainframes after birds. So ironically enough, IBM's bringing it all together for me. So this is me. I work at a company called Groq. We're an AI inference platform. We're not here to talk about me, though. I do a lot of talking about Groq, as you may have caught on that previous slide briefly. I also teach at Carnegie Mellon. I live in Pittsburgh. And I often start with this tweet when I give a talk about AI, because 2 years ago when Kent Beck posted this, it actually had a meaningful impact on me. If you don't know who Kent Beck is, by the way, Kent Beck is one of the people who literally invented agile software development as a practice. So this is a guy that's like a luminary in our world of technology. And when ChatGPT launched, this was his reaction. I'm sure you've read it by now, but the part that of course really hit me was the value of 90% of my skills just went to zero. And if you were in the vibe coding session this morning and you're a software developer, or you're a guy like me and you teach kids at Carnegie Mellon about software development practices, or you have kids who are going into that field, that hits pretty hard. The value of 90% of our skills just went to zero. And what I like about, though, that he ends this with is, however, that remaining 10% just went up 1,000x. And so I think about this every day. What is my 10%? I'd encourage you all to think about what's your 10% that maybe we can recalibrate towards what is the value that we can all collectively bring to the world. And in my life, that probably involves technology and AI. Okay, so what I want to talk about is why the clicker doesn't work. Okay, I need a vibe-coded clicker. So anyhow, I want to talk about AI, sovereign AI, and global patterns that I'm seeing, that we're seeing at Groq in terms of global deployment of AI inference and compute. So luckily for us as Americans, we have a plan. If you didn't see this last week, the White House announced the AI Action Plan. There's a lot of really great stuff in there. I don't care what your politics are. There's a lot of really great stuff in here in terms of policy towards AI. The intention being maintaining the US advantage that we have in AI and innovation. There's a lot of things in here that I'm going to talk about in a second that pertain to my life in particular, but I'm going to go into those in a second. But again, the good thing is, here in the US, we have a plan. Okay. But so does everybody else. The EU is doing a lot of work. Say what you want about the EU and their pace of innovation. They're doing a lot of work through the EU Commission to build gigafactories to encourage similar sort of sovereign compute across Europe. The Saudis, if you're paying attention, there's a lot of activity happening in the Middle East. We happen to be involved there. I'll talk about that in a second. And of course, the Chinese, this AI plan from the Chinese was actually published, I think, on the order of 6 or 7 years ago. So they've been thinking hard about this for a long time. So why does everybody have a plan anyways? Well, first of all, it turns out that converting electricity into intelligence is incredibly valuable. I don't need to tell you that NVIDIA is the most valuable company in the world, but when you put them side by side with the rest of the most valuable companies in the world, them being worth more than Meta and Alphabet combined is a little mind-blowing when you look at market cap. So there's a lot of opportunity here for all of us, all of our businesses, all of our industries, whatever it is that you do every day that sort of contributes or participates in this generative AI wave. There's a lot of value to be created for us, for our customers, and for the world. Why else? Well, there's a lot of these global AI trends that are starting to emerge. I sort of alluded to data and compute residency, but thinking about providing sovereign AI capabilities to your citizens or the companies and enterprises that operate, or your government inside of your country, is a real trend. It's like when electricity was coming out 150 years ago, you couldn't operate a modern nation if you weren't operating your own electricity grid. And countries are coming to the realization that you're not going to operate a modern nation unless you're operating your own AI compute grid. AI security standards, people are concerned about their data, concerned about where that compute is happening. There's this explosion of model ecosystems, from open source models coming from companies like Meta to amazing closed source models like the ones we all probably use every day from OpenAI or Anthropic. And then just the explosion of inference speed and cost. And these are just some of the patterns that I've observed in my time kind of traveling the world talking about this topic. The other reason is why is that the whole thing is really going to converge to inference. I'm going to talk about what inference means in a second. But this is using models, bringing value from these models. OpenAI has spent a ton of money training the models that they brought to life for us to use every day. Anthropic has done the same, Meta, Alibaba, and all the organizations that are bringing these foundation models to life. Yes, they spent a lot of time, energy, resources to bring those models to life by training them. But the work is doing inference. Most of the compute cycles that you're going to be doing as a citizen, that your organization will be doing on behalf of your employees or your customers, will be in inference. This data happens to be Menlo Ventures. I've got another link in there from Accenture. I'm sure KPMG has published similar data. That is, most of the work, and this is 90% if you ask Menlo Ventures, is going to be the work in inference. And if you think about it, as we move into the future and people are using AI and generative AI every day in their life, we're not going to be training models all the time anymore. Yes, there'll be work to continue to fine-tune them and keep them up to date, but all of us and all the vibe coding that we're going to be doing and all of the enterprise applications that are going to be built running on AI, like the ServiceNow and Salesforce folks talked about earlier, all that work is inference. I probably don't need to tell you this, but this is going to be huge. If you look at the chart that's kind of on the front of this, this is from Bond. They just did some research and published it a couple weeks ago. I'd encourage you to go find it, by the way. Mary Meeker, who used to be the queen of the internet, if you remember her, over the last 15 years, participated in this research. It's really comprehensive. But if you look at ChatGPT adoption as sort of a proxy for AI adoption around the world, it took 23 years for 90% of people outside of North America. This is outside of North America. It took 23 years for 90% of people outside of North America to be adopting the internet on a regular basis. It's taken 3 for ChatGPT. And this isn't necessarily, yes, it's amazing for ChatGPT and OpenAI, but if you take that as a proxy for generative AI adoption, 3 years. So people like to compare this. I think the analogy of maybe this will have the same impact that the internet had, I think that's a little bit lame and falls short. I think it's probably more like electricity. Like, this is a really big deal, and it's happening fast. So if you go back to the AI action plan, there's a whole lot of stuff in there. I just wanted to call out a couple of them because these happen to relate to my life. There's a big focus on building American AI infrastructure. And that means a lot of things when you go through the details in the action plan. It literally means advanced manufacturing. It literally means onshoring of manufacturing for silicon, for chips. Groq happens to make a chip, for example. So bringing that manufacturing into the United States, reducing reliance on, say, Taiwan Semiconductor and the geopolitical risk that represents for the United States. There's a big focus on bringing that infrastructure into the United States. But it also is a focus on data center and compute infrastructure, electricity grid. There's a specific call out about modernizing the electricity grid to make sure that we have the power to power the systems that we're trying to build together. So I mentioned building AI infrastructure. It just so happens Groq has a fully North American supply chain. We manufacture our chips in New York. We have a new generation of chip coming out later this year that will be manufactured in Texas. And then we do our final assembly somewhat in the United States, a little bit in Mexico, a little bit in Canada. That helps us avoid some tariffs as that uncertainty continues to linger. Also looking at compute access. In her introduction, she mentioned that Groq has on the order of 2 million developers that are building on Groq. And the idea here is to bring, not just for Groq, yes, I'm talking about Groq now, but not just for Groq, but the part of the US action plan is to get everybody involved in this innovation cycle. How do we bring compute to every kid in every school? How do we bring compute to every innovator, every startup, so that everyone has equal access to the power that can drive their innovation? This is an important call out, again, as a part of the action plan. There's a specific call about open and competitive ecosystems. This future that we all imagine that we're aspiring towards isn't going to work on the back of one company, on the back of one partner, on the back of one chip vendor, on the back of one model. We need to have open and competitive ecosystems. There are specific callouts around open source software. And how do we ensure open models are a part of the ecosystem that we're using going forward? And how do we encourage the safety and the governance and all the things that we'd expect along with that? So for Groq, we run all these, we're committed to having the latest state-of-the-art models available to our customers and our developers. And the thing, I'm not here to tell you a lot about Groq, but the thing that Groq is most known for is speed. And so you can see this is Kimi K2. If you're not familiar, it's maybe the current state-of-the-art model that'll probably change this afternoon at the pace of how these things go. But Kimi happens to be maybe the state-of-the-art model as of today. And you can see speed comparison from running that on Groq to some of the other options. Okay, so we're all going to need inference, whether we're citizens consuming AI every day in our lives, whether we're running large organizations, whether we're building startups, we're all going to need inference. But if we're all going to need inference, how much inference are we going to need? So naturally, I asked ChatGPT. So what I actually asked was, how much inference do I use? So I probably use ChatGPT more than maybe the average person does. But I look back at my consumption of ChatGPT over the past, I forget what it was, a couple of months or whatever. And I use on the order of one, a little bit less, token per second. And if you're not familiar, a token is like the currency of AI systems. So you can imagine like a sentence, if your country ran AI like electricity, the models break that into tokens. It's not exactly each word is a token, but for simplicity, you can imagine that to be that way. And so me, as a probably above average consumer of ChatGPT, I use about a token per second of inference. So if that were the case, and we wanted to provide AI inference capacity for everybody in this country alone, you're looking at like 32 trillion tokens per day of AI compute capacity. Not only is 32 trillion a big number, but that's actually a lot of token capacity. For for a nation the size of the United States, about 300 million people. But then you look around the world and imagine how that number scales when you talk about a world of 6 billion people or more. How much compute capacity are we going to need to power that? So this is really a nation-scale infrastructure problem. Again, think of it like we're running an electricity grid. And what would be the strategic things we'd have to do as a country to make sure that our electricity grid was sufficient to power the electric needs of our country? The same applies to generative AI. How are we going to build enough data centers, provide enough electricity, provide enough compute, the chips that are necessary to power these things? Quantum may become a part of that in the very near future, it sounds like. But how are we going to do that? Brief commercial on Groq, but when you look at what Groq is bringing to the market, it is both speed, and I'm going to talk about some examples of our speed here in a second, but it's also economics. If we're trying to provide 32 trillion tokens per day of capacity for the United States for people to power their AI ambitions or their citizen AI use, we're going to need a lot of compute, and it's probably going to be expensive. So again, we don't want to rely on one technology. We don't want to rely on one vendor. We don't want to rely on one model. We want to be able to spread that wealth around and make sure that we're making the right economic choices for our country or for our organizations. And this is a place where Groq really does well. The one on the far right is kind of interesting to me personally because I said at the beginning I kind of grew up as a data scientist and I didn't spend a lot of time thinking about how much electricity does this price elasticity model that I'm building consume. I can admit that I never thought about that ever. But these are real factors. How much electricity is going to be necessary to provide a nation with 32 trillion tokens per day of AI capacity? By the way, the answer is a lot. So we're going to need to find power-efficient solutions to deliver that. So some of the patterns and lessons that I'm talking about are because at Groq, we've already done this 3 times. You may have seen in the news, if you're following Groq much at all, we have a partnership in Saudi Arabia with a company called Humane. They're a pure-play AI company. And we set out towards the end of last year to build one of the world's largest AI inference compute centers in Saudi Arabia. We brought this thing to life in 51 days. So I said Groq is known for being fast. Yes, if you run AI applications on Groq, they run fast. But we can also bring this compute power to life very quickly. So in 51 days, you can see the 747 loaded up with all the Groq stuff, shipped it off to Saudi Arabia, stood it up in a data center, turned the thing on, and that system today is capable of about 4 million tokens a second. It doesn't come anywhere close to 32 trillion tokens per day, but it's a pretty powerful compute center that we have in the Middle East. We've also recently announced a partnership with Bell Canada. So we're going to be building a couple of inference sites around Canada, again, powering the Canadian government's sovereign AI needs. They're doing so in partnership with Bell Canada. We're seeing similar patterns emerging across Europe, where the EU Commission is sponsoring these gigafactories that I mentioned a second ago. And the telco providers, of course, have sort of an advantage as being the backbone for networking across the country. So we're partnering with Bell to bring AI sovereign compute to life for the citizens of Canada, for the large enterprises across Canada, and for the Canadian government. We happen to be partnering with a company called Cohere. If you're not familiar with Cohere, they're a foundation model builder based in Canada, actually. We're also doing this in Europe. So we just announced, also a couple of weeks ago, our first expansion into Europe. We have a site operating in Helsinki in Finland. The beauty of operating an AI inference center in Finland or in the Nordics is one, there's access to a lot of green energy. So the power consumption footprint is incredibly advantageous and positive for Groq. Also, data centers generate a lot of heat. So we can just open the windows and let the cold Finnish air blow through and cool the thing down. That's actually not totally far from the truth. They have, like a vent on the ceiling and they do blow the cold air in. But anyways, so we've done this a couple of times. And again, the pattern behind all of these is whether you're the EU or Finland in particular, whether you're Canada, whether you're Saudi Arabia or the United States. We, of course, have, by the way, lots of inference sites all over the United States. Is that you're trying to power this ambition to serve sovereign AI to the people of your country, to your government needs. You imagine you're the Canadian government, and you're going to be doing AI in the defense space, for example. It's hard to imagine you're going to want to run that in an American data center, for example. These are nation-state concerns. And we've learned a lot of lessons doing these things in a couple different parts of the world. I mentioned the one in Saudi Arabia. We put that together in about 51 days. The one in Canada was about 30 days. This one in Europe we did in about 15 days. So we're getting faster and faster and faster at our ability to deploy sovereign scale compute for these countries. So I'm going to close on this next slide, and then I'll leave myself 2 minutes for questions. I mentioned that these things are going to be expensive. So how do you factor in scaled economics, whether you're thinking about sovereign AI or you're thinking about AI for your organization? How do you think about the economics at scale to power all of the ambition of your employees or all of the AI needs of your customers? Getting there quickly, I mentioned that we're doing these things now in 15 days. So how quickly can you spin up your AI compute and your AI inference center? There are stories upon stories upon stories of long wait times. New chips come out from NVIDIA and Elon buys them all. So now we're all just in line waiting after that, right? So getting there quickly is incredibly important. And like I said, we've done this 3 times already. So, reducing the risk of what it takes to deploy these things. All righty, great. Well, thank you very much.